All right, so let's talk about the three types of chemical bonds. The main thing we need to remember is the types of elements on the periodic table. So, everything that we see in yellow here, they are all metals. They make up the majority of the periodic table. The ones in blue are nonmetals. They are the second most abundant type of element. Remember, hydrogen is a nonmetal, though it lives with the metals. And then along the staircase are the metalloids. They're the ones in green. Now, the metalloids, they have properties of both metals and nonmetals, or some of their properties. But in terms of bonding, they're going to act like nonmetals. So, let's talk about the three types of bonds. Ionic, metallic, and covalent are the three types of bonds. Ionic bonding occurs between a metal and a nonmetal, or we can say between a cation and an anion. Now remember, cations are positively charged, anions are negatively charged. Cations have lost electrons, anions have gained electrons. Metallic bonding occurs between two metals, and then covalent bonding occurs between two nonmetals. So we're going to go into greater detail about each type. First one is metallic bonding. This is called the electron C model because what ends up happening is all the different metals in a metallic bond share all of their valence electrons. So it's called a sea of electrons. This sea of electrons are shared by all the atoms and move throughout the structure. So they are called delocalized electrons because they aren't centered around any particular atom anymore. They are not localized around any particular atom. They are delocalized. So because of this, it leads to some pretty interesting properties about metals. Like, they have really good thermal and electrical conductivity. Think about it. We use metals for our cookware, our wiring for electricity. We use it for a lot of different stuff, and it conducts heat very well, and it conducts electricity. Conducts heat well because those atoms are really close together. The heat can travel from atom to atom to atom. Conducts electricity because those electrons are being shared among all the different atoms, so the current can travel from atom to atom to atom and down the wire. Metals are also very malleable, which means they can be hammered into thin sheets like aluminum foil. And they are ductile, which means they can be drawn into a wire like copper wiring. And that's pretty much it for metallic bonds. Next type is ionic bonds. Remember, this is when it's a metal and a nonmetal, or a cation and an anion. Remember, again, positive ions are cations, negative ions are anions. This involves the transfer of an electron from the metal to the nonmetal. All right, so this little picture down here, we have a sodium atom, and it has one electron right there. It gives that electron to chlorine because chlorine has 7 valence electrons. Sodium had 1 valence electron. Remember, the magic number is 8. We want to get to 8 valence electrons. So chlorine just needs 1 more to be happy. Sodium has 1 extra to give, so sodium gives its 1 valence electron to chlorine. When this happens, sodium ends up with a +1 charge. Chlorine ends up with a -1 charge, and the thing that holds them together is called electrostatic attraction. It's like North and South Pole magnets. When they come close together, they're going to attract. Positive and negative charges attract. Ionic compounds, it's not just one individual sodium and chlorine, sodium ion and chlorine ion. What it actually is an entire crystal lattice structure. And ionic compounds are solid because those bonds are really strong. They have very high melting and boiling points. So these are going to be solid at room temperature. And there's a whole structure that makes up the ionic compound. However, I say that ionic compounds are the strongest bonds, but most of them will dissolve in water. When they dissolve in water, they can conduct electricity, which means that they are electrolytes. But they have to be dissolved in water or melted down. The ions must be able to move. Otherwise, they will not conduct electricity. Covalent bonding. Remember, covalent bonds is between two nonmetals. This occurs when electrons are shared between atoms, right? And then this is just FYI. We're going to go into this in greater detail later, but if they share 2 electrons, it's called a single bond. So one covalent bond is a pair of 2 electrons. Sharing 4 electrons is called a double bond. 6 electrons is a triple bond. And then a little preview into polarity. Again, we're going to go into this in a lot greater detail at the end of the unit. But polar bonds occur when there is an unequal sharing of electrons. And the elements that are hogs are nitrogen, oxygen, and fluorine. So it's where one atom is hogging the electrons a little bit more than the other, and so it's an unequal sharing, or it's a polar bond. Non-polar bonds, it's going to be an equal sharing, and the elements that they're friendly and they like to share equally are typically carbon and hydrogen. But again, we're going to go into that in a lot greater detail later. Covalent compounds will exist in any state at room temperature, unlike ionic compounds, which were all solids. But covalent compounds are kind of all over the place. But they typically have lower melting and boiling points than ionic compounds. So let's just do a little bit of practice. So we're going to determine the bond type of these different atoms. Of these different compounds, not atoms. So we're going to determine the bond type for these 8. So NaCl, sodium is a metal, chlorine is a nonmetal, so this is going to be ionic. CO, well, they're both nonmetals, so it's got to be covalent. FeNi, they're both metals, so it's metallic. SiS2, well, S is a nonmetal, but Si is a metalloid. However, metalloids will act like nonmetals when they bond, so this is a covalent compound. NCl3, they're both nonmetals, so covalent. Same thing with PF3, they're both nonmetals. CaCl2, calcium is a metal, chlorine is a nonmetal, so it's ionic. Same thing with Fe2O3, iron's a metal, oxygen is a nonmetal.